Everyone, myself Shivam. So let's get started quickly to question B where we left earlier. Nasya and the door. So you can pause the video if you wanna read this question. I'll just brief it out so that we can move faster. In this question, there is given that Dennis has created a door of length k which will be of greater than equals to 3, and we have a sequence of n numbers in which there is a number which called a peak if it is greater than its left adjacent and if it's greater than its right adjacent. That means the middle element is bigger than both of its sides, then it's called a peak. So when this k length door is fall upon this sequence, say it will cover it is of length k, so it will cover k elements in the given array. If we suppose this is the array and k length is 3, then it will cover 3 to 9 elements in this array. So if there are two peaks in the given segments which of length 6, then the door will be split into 2 plus 1, that is the number of peaks plus 1. We have to find what will be the maximum number of pieces the door can be cut into, and if there are more than one solution, that is there are more than one segment in which there are maximum number of pieces in which the door can be cutted, then we have to choose the segment which have the minimum lower bound, that is the starting point of the segment should be minimum, that is L should be minimum if have a segment L to R. So quickly gets to the understanding part. Here I have represented what's a peak look like. The middle element should be greater than this left one and the right one. Suppose we have this array, these are the positions and these are the values of the array. So if k equals to 6, we have assumed that k is equals to 6, then what will be the segments which divide this k? The first segment will be from 1 to 4, the second segment will be from 2 to 3, and the third segment will be 3 to 2. We have seen in this first segment there is only one peak, in this second segment there is only two peaks, and this third segment there is only four peaks, one peak, sorry. So we are clear that we will choose this segment as the number of peaks is greater in this segment, so we'll get the maximum number of pieces here only. If there will be multiple segments where the peaks are equal, then we will choose the one which have less L. So in question like this, you have observed that if we take segment as a window, then it will slide left one element and slide to one new element is added to it. So in these questions, we generally use a data structure known as DQ, which make our work easier as we can add an element to its back as well as front, and also remove an element from its front as well as back. So if we take these are the three segments, first we'll calculate the starting segments. How many number of peaks are there in the first segment? We have calculated that number of peaks in the first segment is only 1, which is on the position 3. So we push the position in the DQ, which will be useful later. After the segment slides, one element is removed. Now here what DQ will be useful. We will check the element which is removed last. Is it contributing in the peak or not? If it's contributing in the peak, then the number of peaks in this segment will be the number of peak previous in the previous segment minus 1, cause this element is contributing in the previous segment but it is not present in this segment, so it will not contribute here. And the new element which is added to our segment, we will check due to this addition is there a increase in number of peak, so we'll get the new resultant number of peak and if our answer which was calculated earlier is now greater, then we'll edit it. The new peak position will also be inserted in the queue. So like this wise we'll go on till our last segment is reached, and when we'll get the maximum number of peak, we'll print it out. So let's get to the coding part. Here I have already written the code, so just go through it. I have initialized t, which will be useful for taking the test cases, and while t minus minus to run all test cases, and the number of element k, the length of door I for iterating. I have taken the input, initialize a vector. Those who don't know what our vectors are, they are simply dynamic array. I have taken one base indexing cause it will be helpful for me to calculate things later on. If I have one base indexing, I have initialized a dq count array which will count the current peak in our segment, answer which will count the final answer, and index equals to 1. Here I have initialized index equals to 1 as if we have an array in which there are no such peak, then the answer will be automatically 1, but the index should be always 1. It can't be less than 1. So I have initialized index with 1. I have first taken the range L equals to 1 and R equals to K, that is our first segment from 1 to 4, and calculated simple using for loop. If A of I is greater than its right adjacent and A of I is less than its left adjacent, then we simply increase the number of peak and push back the value of position in the queue. If our answer is less than count, then we update our answer and index as 1. Now after this loop ends, we have all the peaks in the first segment. I have increased the L and R for the next segment. As L increases, L is now here on 2 and R is here on 1. Now while R is less than N, we will calculate number of element left. That much number we have to calculate. So if our queue is not empty, then we'll check if our new position, that is 2, is this contributing in the peak. If it is yes, then we will decrease the number of peak in this segment. This part I have explained here. If this element is gone and this will be the first element of the segment, then it cannot contribute, it cannot be counted as a peak if it was peak earlier. So if AR of -1, that is the new element which was introduced, 1 was the R, then 4 is 4 can be considered as a peak cause it has right adjacent as well as left adjacent. So we see if this element is our peak or not. If it is a peak, then we increase the count and push back the new value of the position of the peak, and then again we count that. If number of peaks current is greater than answer, then we update the answer as well as index, or index equals to L. L was our starting index, and while this loop will run, it will automatically put my answer to greatest value, and we simply see out answer plus 1, as we have always calculated in answer what is the number of peaks, but the output should be pieces, and pieces is equal to what, peak plus 1 and our index. So let's run the code. So here you can see we get our desired result. That's it for this video, guys. If you like this video, please like and subscribe, and also ring the bell icon for the latest video updates. Thank you.